Friends, this is part 3 of question number 1. We have seen the first two parts of the first question. This is the C part, and the question here is saying, briefly explain why the two graphs must be the same using physics principle. What has happened? So this dashed line is showing the potential energy versus the kinetic energy graph of the system after the block is dropped. So initially, this single block was doing simple harmonic motion, okay, with the help of the spring. M naught was at the extreme position. This block of 3 M naught mass is gently placed on this block here, and then the two blocks stick together, and thereafter they continue doing SHM with a combined mass of 4 M naught. The question is saying that till the graph between kinetic energy and the potential energy is the same as before. Why is that? Explain why the two graphs must be the same using physics principle. So, when this block was not dropped, was not attached to this M naught block, so it was simply like this. It was doing SHM with this M naught mass here only on the surface. Okay, there is no friction, of course. In this case also, the total energy was 4. The total energy of the system was 4. So obviously, the maximum kinetic is going to be 4. The maximum potential energy is going to be 4. And this happens when? At this point, the potential energy is 0. At this point, the kinetic energy is 0. This was the situation. But even after you are placing this 3M naught block on this one, even after that, the energy, the total energy of the system remains the same. Yes. And the graph of Ke and P is also the same as it was before. Why is that? It is because the total energy of the system is not changing. If this block is gently placed on this M naught, no external work is done. Okay, no energy is being given to the system from outside, or the system is not losing any energy. It is gently placed, right? And they stick to each other, right? The forces between the two blocks that, keeping them together, that make them stick with each other, is not doing any work. Okay, there is no, relative movement between the two blocks. Okay, there is no work done by that force. There is no external energy added, right? The internal force between these two blocks is not really doing any work on the system. The total energy of the system remains conserved what it was before. Okay, it was 4 joules earlier, it is 4 joules now, and it remains the same. So the maximum kinetic energy is still 4, and the maximum potential energy is still 4 joules, and the total energy is also 4 joules. So, but what is the change that has occurred here because of adding this? The change that has occurred is the speed at the mean position will be slower this time. Because the mass has increased, the speed at the mean position is going to be lesser. So the total energy is kinetic energy plus potential energy at any position, any given point of time, L plus L. This is the mean position 0. This is the minus L position, minus L. Okay. This is any position X, let's say. What is the energy of the system when this is at a random position X from the mean, this 0 here? Energy in that case will be given by the kinetic energy is half mv square. If the velocity at this time is v, okay? At this particular moment, if the velocity is v, plus half kx square will be the potential energy stored in the spring at that particular moment. It will be the potential energy stored in the spring at that particular moment, half kx square. The total energy is not changing. So at the extreme position, okay, just see this part, the potential energy of the system, the spring is not changing. So the magnitude of the, so the amplitude is also not going to change. Okay. So the amplitude is still going to remain L only, from 0 to L this side and 0 to minus L this side. The amplitude of the SHM is also not changing here. So this part is, the maximum is going to be half K L square. This is the maximum potential energy of the system. Still it is. That is equal to 4 joules, of course. So half K L square is equal to half 4 m naught. This is the new mass into V naught square. If V naught be the speed at the mean position, okay, at the mean position, if the speed of the 4m naught block is V naught, this is equal to, this is equal to the total energy of the system, 4 joules. So for this one also, if you make a graph, you'll get the same thing. The maximum energy, this is the kinetic energy, this is the potential energy. Okay. Obviously, if you make a graph, the maximum potential is 4 and kinetic 0. This point here is kinetic 4. So this is like 0 comma 4 and this is 4 comma 0. Obviously, if you connect these two lines, you'll get this dotted curve here. Okay.